In module 15.2, we're going to be dealing with isosceles and equilateral triangles. And in isosceles triangle is a triangle that has two congruent sides. So let's take a look at an example of one. Let me just use a quick sketch feature. Okay. So say that's my isosceles triangle. And this side is congruent to this side. And I can label certain features of this, and this is certain terminology that we would use with something like an isosceles triangle. So these right here would be referred to as the legs of the isosceles triangle. So those are the congruent sides. Opposite of those legs, we have right here and right there. Those would be the base angles. And the base angles are actually congruent. So the angles opposite the sides are also congruent. And then we have what we would call the base. This segment right here would be referred to as just the base. And this angle would be referred to as the vertex angle. So this essentially just leads us into our theorem. And this is a theorem which we essentially proved in class using the geometry tool. So let's write it out. Isosceles triangle theorem. And that states, let me scroll this, if two sides of a triangle are congruent, then the two sides, sorry, not the two sides, then the two angles opposite the sides are congruent. So what that means, if we draw our isosceles triangle, watch me draw my perfect isosceles triangle. What a wonderful triangle that is. So again, if we say that, if we say that this side is congruent to that side, then that means the angles opposite of those sides are also congruent to each other. Remember, these are our congruency symbols. And that's all that the theorem is saying. So let's take a look at an example using our isosceles triangle theorem. We're asked to find the measure of angle T. Oops, I should probably label this for you. So this is T, this is S, and then this is R. So we're asked to find the measure of angle T, and right now it says 3x, and we're given that angle R is just x. Okay, well, I remember that opposite angles of an isosceles triangle are congruent, and I know that this is an isosceles triangle because of these congruency symbols. We got two legs that are congruent to each other, so that means angle S must also be x. That's my little degree symbol, by the way. Actually, I'll make it a little cleaner. There we go. And due to the triangle sum theorem, I know that the measure of angle R plus the measure of angle S plus the measure of angle T equals 180 degrees. And we do have values for all three of those angles, so let's just substitute them in. Measure of angle R is x, the measure of angle S is x, and the measure of angle T is 3x, and they equal 180 degrees. X plus x is 2x, and 2x plus 3x gives me 5x. 5x equals 180 degrees. And now I'm just going to use inverse operations, divide both sides by 5, and I get x equals 36. So I just found the measure of x, which is angle R and angle S. Remember what the question was asking. It was asking for the measure of angle T. And the measure of angle T equals 3x. So let's go ahead and substitute that 36 in for x. And we get the measure of angle T equals 3 times 36, which equals 108 degrees. So that would be our answer. Okay, so here's kind of a very basic theorem dealing with equilateral triangles. So, I'm about to run out of battery. Let me finish this up quick. Equilateral triangle theorem basically states that if a triangle is equilateral, meaning all three sides are congruent, then they are also equiangular, meaning all three angles are congruent. And the converse to that also applies. If a triangle is equiangular, then it is also equilateral, meaning all three sides are congruent. Very basic, very simple. So if it's equilateral, it's equiangular. And I'm going to write that right in the middle, maybe in blue. I'm going to point out the equiangular ones. So equiangular. That would be these triangles. Oops, sorry class. I just noticed I made a big spelling error. Let's do that again. Equiangular. There's no L in the middle, so it's just E-Q-U-I-A, then angular. There we go. Much better correction.